Hello, what's up guys? Welcome back to my channel. My name is Tony and today we're going to cover another BFS problem. So open the lock. Let's go ahead and read the question. You have a lock in front of you with the 4 circular wheels and each wheel has 10 slots. So 0, 1, 2, 3 all the way to 9. And the wheel can return freely and wrap around. For example, that 9 can turn to 0 and 0 can turn to 9. So it's more like a circular shape. So we have 0 all the way to 9. So 0 can turn to 9 and 9 can turn to 0. So we got it. And each move consists of turning one wheel, one slot. And the lock initially starts as 4 zeros and a string representing the state of 4 wheels. This is our initial position, and you are given the dead ends, and dead ends means if the lock display any of this code and the wheel will stop turning and you are not able to open it, and given a target representing the value of the wheels that will unlock the lock, return the minimum total numbers of the turns required to open the lock, and or -1 if it's impossible. So basically we are given the initial position and we want to go all the way to the target position. So we're going to go from 0 0 0 0 all the way to the target position by shifting the numbers one step at a time. So how do we do that? And for example, we are starting from 0 0 0 0 and we can change this value to 1, or the second value to 1, or the third value to 1, or the fourth value to 1, and each turn so we can get one step closer to our target value. But unfortunately there's a restriction, which is the dead ends. So those are the dead ends. If we are able to reach one of the dead ends, we'll stop right there. So that's why we're trying to avoid and going into those positions. So in order to go to 0 to 0 2, we don't want to go to we don't want to increment, for example, this value twice and then increment this value once, and in order to get this value, because we are going to reach to the dead end instead. So I would just increase this value twice, and it becomes 0 0 0 0 2 and increment this value. Okay, we can do that as well unfortunately. So let's see what's the valid move. So the valid move will be increase the first value and it become 1 1 0 0 0, and increase the second value and let the second value become this, and go ahead and keep moving and eventually reduce from this value and to this value. Eventually we actually have a detour. Actually is kind of waste of the steps, because we the best case scenario without restriction, we are not necessarily increment this value, but unfortunately because we have the dead ends, so we have to go one step forward and eventually reduce this value in order to get the target. So now we got the steps, and what are the steps you can solve this problem. So this week we are solving BFS, and in this video I'm gonna cover BFS, but I think DFS can also solve the problem. So let's check the topic. Okay, so I think this problem designed for the BFS. Okay, perfect. So the BFS basically simple. We start with the 0 0 0 0, and I'm gonna modify each value in the spot. So for example, we start from here and I'm going to increment this value and decrement this value. So I'm going to do 2 operations for each value within this node. So I'm going to modify this value and modify this value and modify this value and modify this value, and I'm going to put all the modified value into my queue, and eventually I'm going to check all the values in my queue, and I'm going to pop this out with the different steps, and those values got popped out from my queue will keep being modified until I reach the target. So in the meanwhile, if any of my states reach to the dead ends, I'm gonna continue. I'm not gonna modify this, because we already reached the dead ends. So I'm gonna give up on those nodes, and for the rest of the nodes that was still able to reach out to the targets, I'm gonna go ahead and keep modifying. And then in the meanwhile, I'm gonna have a visited hash set and to modify the position or the state that I have been visited. So now let's go ahead and do the coding part. Like the regular BFS, so we are gonna have a queue. In this case in Python, so we're just gonna have a DQ, double-ended queue. So once we have the queue and we put the initial position into the queue, and that's gonna be 4 0. That's our initial position. And same thing, we're gonna have a visited, so which is a hash set, And for the same part, so the hash set, we're gonna put the initial position as well. So that means like we already visited this part. So once we have that, and we can go ahead and write in the loop. So the while loop is gonna be doing exhaustive search and until like we are seeing the final results, like we are reaching out the target. And then the first part is okay. So before that, and remember we have the dead end, and that end is gonna be a list which is not perfect in terms of searching, because once we reach to any of the states within the dead end, we are gonna continue. So we're gonna give up on that state. Having a list is not perfect, so we're gonna convert it to hash set as well. So because we are checking whether a position is in there or not, so without any duplicates, so we can just have the hash set to check that with O1 time complexity. And the next step will be for each layer, for example, that I'm modifying on top of 4 zeros, and in the first round I'm gonna modify the first value, second value, third value, and fourth value, and I'm gonna put all the 4 modified value into the queue, actually 8, because I'm gonna increment and decrement, and I'm gonna put all the 8 modified value into the queue, and then based on the 8 queue, I'm gonna generate the next layer. So each layer I'm gonna modify how many steps we are reaching. So because each layer represents like each step, so I'm gonna have a step represents my total results. Okay, so once we have that, and we because we are doing this in the layer position, so we're gonna have the size recording how many node within this queue. So in the first position, like in the initial position, we only have 1 4 zeros within this queue, so we only have 1 as a size, but in the future we're gonna have more as the same layer. So that's why we're just gonna modify like this. And then we gonna do this for loop, so they are all in the same layer, and we're gonna modify them all together. So the node will be popped out from the queue, and once we pop this from the queue, and then we can start checking the final position. So if the node is equal to the target, so that means like we already reached to the final target, so that's great. So we just simply return the step. If not, the worst case scenario is that the node is in the dead end. So the node is in dead end. We're gonna continue because we can't do anything about it. So we are not gonna unlock the lock in this case because we already reached the dead end. So self-explanatory. And we can go to the next steps is we start modifying. The node will be initially as 0000, and that's not the target. That's not the target, and we're gonna modify on top of this. But how do we do that? We're gonna increment this value, and decrement this value. And for each of the value within this node, we're gonna increment and decrement. How do we do that? So we are basically gonna have a for loop, right? And the for loop will be the length of the node, and because we're gonna modify every single number on top of the node, and we take the each number on top of this node, and we convert that into an integer. So right now we're in this string, so we're gonna take out every single position as an integer. So once we get this integer, we're gonna increment or we're gonna decrement. The way we're gonna do that is we're gonna have a for loop and just loop to -1 and +1, and we're gonna have a new number, which is the modified number. So far we're taking this number out, and we're gonna modify this number to either plus the dx, or plus the 1, or minus the 1, or plus the 1. So the way we do that is new number is gonna be num plus dx, because dx could be either -1 or +1. And we take this as a parenthesis, and one special condition is if we have 9 and then we +1, it's gonna convert it to 0. So the way we do that is by mod 10. And the same thing, 0 can convert to 9 by -1, right? 10. So the mod will take care of that. So, and this 2 position is being taken care of by this line, and everything is great. And for the rest of the numbers, like 1 plus 1 will be 2, and they're not across the boundary. So those are like the typical standard operation. Okay, so now we got the new numbers. So we're gonna put this number back to the node, and by form a new node. The new node will be the old node all the way to I. This is a string slicing within Python, and we're gonna modify this. So the number we got is a num, so we're gonna convert that to a string. So we convert this particular new num, new num into string, and plus the node all the way from I plus 1, because we already replaced the ith position, and we can go all the way from I plus 1 all the way to the end. And we already have the new node. And do we need to do any operation within the next layer? So we have to see, how do we check that? We check if we already do any operation on top of this node. So is this already being calculated? So if it's not, and then we can go ahead and calculate it. And the way we do that is we put the new node into our queue. And same thing, the visited needs to be record whatever we already put into the queue, so we don't have to recompute this every time. So if none of this actually works, so we return -1. That means like we are never have a way to reach the target, so that never works. And another thing is the steps. So I think once we finish the coding, we have like more clear picture for the steps. Steps start with the 0. So for each operation on one node, one layer of node, and we're gonna +1. So the way the place we're gonna +1 is right here actually. So this is actually corresponding to the for loop, because for each node we are generating. And when we go into the next layer, and we're gonna +1. So the for loop stands for each layer. Okay, so once we have that, that should work. Oops, okay. DQ. Okay, it works. Okay. I don't think we need any recap. I feel like it's pretty self-explanatory for this problem. Okay, I'll see you guys in the next video.